This is the AP/AB Calculus notes for section 2.1, which deals with the tangent and velocity problems. Our first content objective is to understand that the tangent line can be viewed as a limit of secant lines. And before we can accomplish this objective, we need to revisit this old vocabulary of tangent line and secant line, and then connect it to this new vocabulary word of a limit. So before we get to the limit, let's go back to our old definitions that we encountered in geometry. In geometry, if you recall, we had tangent lines to circles and we had secant lines to circles. And how they were most likely defined in your geometry courses was by the behavior or the number of intersections that the tangent line had with the curve. So if we look here, we could see that the tangent line intersected that circle at exactly 1 point, whereas the secant line intersected the circle at 2. The difference is that when we move into the calculus world and we are no longer working with closed geometric shapes and we're instead dealing with curves that have domains outside of the limited domains of geometric shapes, then our old definitions of intersecting 1 time versus intersecting 2 times are no longer going to work. In both of the black line scenarios, we have 2 tangent lines, but this particular tangent line, if we were to continue it, we would see that it would intersect this polynomial a minimum of 2 times, depending on the behavior of this polynomial once we get outside what we can see in the domain. So we have to revise our definition of tangent lines so that it will still work in both scenarios. So what we're going to do is we're going to look at the behavior of the tangent line in relationship to the curve and then contrast that to the behavior of the secant lines in relation to the curve. So one of the things that we notice about this black tangent line and the curve is not only do they touch at this 1 point of tangency, but they also touch in a specific way that is very different from the way the secant lines are touching the curve. So if we look here, we can see that the tangent line is actually somewhat kissing this blue curve, and the curve bows away from the tangent line. We see the same behavior over here when we're bowing away from the black tangent line here. Whereas by contrast, we have the secant line is just cutting straight through the curve itself. It's not touching it in that same kissing format. It's actually cutting through. So we can say that the definition of our tangent lines are going to stem from not just that the secant line contains 2 points or more depending on the curve, but we can say that a tangent line is now going to be a limit of secant lines which contain the same endpoint. Now that might seem a little cryptic to some, so to help you with that, I'm going to pull up a video that I was able to find, done by a professor at Houston University, I think it was. So let's open this and watch it, and you can see how a tangent line can end up being viewed as a limit of secant lines. So before I hit this, we're going to describe what's going on here. Remember here we're going to contain the same endpoint. So here I've got this black point, which is the point of tangency, and I have this dotted line here that is the tangent line. And I'm going to create a secant line by choosing a second point on the curve and then connecting the black to the blue and creating this blue secant line. Now ideally we want the tangent line, which is just kissing the curve at this 1 point, to be created by moving this blue point. So if I drag this blue point along the graph to this point and I let the line go with it, then the blue secant lines will eventually collide with that tangent line that is dotted. So in essence, the limit of the secant lines will become this tangent line. It doesn't matter whether that blue point is to the right or if that blue point is to the left. Either way it will work. So let's watch and see how that goes. So in this way, our tangent line can now be viewed as a limit of secant lines which contain the same endpoint. So we're going to do a practice looking at this problem. Here I've got a curve that is y equals x squared, and I'm interested in knowing which of the lines A, B, C, D, or E are actually going to be tangent to the curve at the point 1, 1. Well, if we look for that kissing behavior, we can see that this line E is actually going to be the one that is tangent because it intersects at just that one point, and it intersects in the way that is deemed as a limit of secant lines. So in your notes, I'd like you to please explain the difference between a secant line and a tangent line in the calculus world using your own words.